Yeah, welcome to our talk, Journey with GraphQL. I'm Faduma, and this is Michelle, and we're both software engineers at Content International, and we love GraphQL, and this is our handles if you want to tweet GraphQL things to us. So what are we going to talk about today? So we're going to talk about two things. We're going to give you a sort of a history on our sort of GraphQL journey and decisions that we made, and general use cases, reasons why you could use GraphQL. So we own GQ and Vogue. Next slide. And GQ is not a magazine about GraphQL, FYI. So this is our beautiful Vogue website. We made this. So a bit of history on what our app used to look like. Yes, thank you. Our app used to look like this, where we used to get data from a content API, and we served it up using a Happy server, and we had a Redux store where we would put data in and server-side render our application. So what are the problems we had, Michelle?
Okay, so here's what our application used to look like, as Faduma showed. And after we'd been building this for a couple of months, we had a retrospective where we talked about the things that we liked and the things that we didn't like about our code base. And here are some of the problems that we identified. The first problem is that a lot of our components were tied very specifically to the API response. So this is a dramatic example of what a component might have looked like for a title. Instead of just passing in the title, we would pass in the entire API response and just get the title. That should be destructured, but ignore that.
Why is this bad, Michelle?
Well, this is bad because if the API changes, you have to update your components. So if the API developer changed the field name from title to head, we would have to update our title component, which is very inconvenient and could be avoided. It's also less readable because it's not clear what data your component needs. So if I was a new developer joining a project and I looked at this title component, it would not be clear to me what data I need to pass it in order for it to render successfully. Our components also know way too much about their context. By context, I mean where the data comes from, the structure that it's fetched in, and all the data that is available. Ideally, we would have a few components that know about context, while most of our React components have no idea. So this would be following the structure of presentational versus container components. So presentational components know nothing about the context. They have no state or dependencies. They just take in data and display it. So if we were to refactor our component to be more presentational, it might look something like this. Meanwhile, we have our container components, which do know about context. They're often generated by higher order components, and they provide data to presentational components and render them. So an example of a presentational component would be something like this for an article page, which gets all the data it's generated by this high order component with article data, which gives it all the data from the API response. And then it renders the title and the byline component and just passes them the data that they need and nothing more. This is a great pattern, but unfortunately, we did not enforce this strictly enough in our code base. And a lot of our components knew way too much about the API and what was going on. In an ideal world, even our container components would not know about the third-party API. More on this later. Basically, our components needed a lot of refactoring. Problem number 2. We sent a lot of data that we weren't using to the client into our Redux store. So this is the full set of data that we would get back when making a request to the content API for an article. It's a lot of data. And a lot of this data, not all of it made it to the client, but a lot of it did.
Why is this bad, Michelle?
This is bad, first of all, because of confusing clutter. We don't need all of this data, so why is it there? It can also affect performance because the browser is downloading unnecessary stuff. It could also be a security risk. What if the API developer introduces a sensitive field like password, and then because we're not filtering the API response, we just send it to the client in our Redux store? We're exposing sensitive data to our users. Moral of the story is, we should not be sending all of this data to the client. Third problem. If we switch data sources, we would have to completely rewrite our entire application. Pretty much everything in our app was closely tied to the API, from the components that we were talking about before, also our analytics and the metadata that we were rendering on the page. They're all very closely linked to the API. And for example, if we switch to WordPress, we would have to throw away our app and completely rewrite it. So if our pink API changed to a rainbow API, our app would kind of be redundant in a lot of ways, which is not good.
Why is this bad, Michelle?
This is bad because technology changes and your app should be resilient. It is a business risk to couple your application to a third-party service. We needed to consciously decouple. Problem number 4. The API was difficult to work with, and it had some quirks that we did not understand because we were not the ones that built it. Disclaimer, this is the case with all third-party APIs, not specifically the third-party API that we were working with. And if you work with third-party APIs, you will probably experience a lot of these issues. Like, first of all, it was not built with our specific use case in mind. Can you believe it? Unbelievable. The field names did not always make sense to us. There were some weird publisher speak field names that people would join our project and not know what they are. There was also so much data, more than we needed, as you saw earlier. And some data, can you believe it, was not in the format that we required. So for example, the article body would come back to us in Markdown, which is convenient for the content management system, but not so convenient for us when we don't want to render hashes everywhere on the page. And also there was not always documentation for the API. And you'll probably experience this when you use third-party APIs, because documentation is hard when it's done by humans. And sometimes we would not know which parameters, which query params we could pass, or what options we could send with the SDK request. And that was hard. Third-party APIs will never be perfect. Problem number 5. We were fetching data in complicated ways from deep trees in the API every time we needed to use it in our main application. So if we wanted to render an article about Meghan Markle, here are the requests that we would make in our main application. There would be a request to get the Meghan Markle article, then the publish history for that article to get the pub date that the analytics required. You'd have to look up the contributor, Michelle Garrett. You'd have to look up the fashion category to get information about that. You'd have to look up recommendations for the article from the recommendations API. And then with the IDs that returns, look up every single one of those articles individually. And then you'd have to smush all that data together to render this article.
Why is this bad, Michelle?
This is bad because it was cognitive overload trying to remember where to get which data every time we needed it. We had some really complex relationships between objects that we had to navigate frequently, like getting the recommendations. We would have to get those IDs and then embed those recommendations objects. And we had to make multiple requests in our main application to get the data we wanted. And we were server-side rendering, but if we were making multiple requests client-side, it would not have been performant. It's also harder to debug because when something goes wrong in this process, it's hard to track down where exactly the problem is. It was a lot to deal with. Clearly we had issues. But how do we solve these problems?
Yes, how did we solve these problems? So we had a retrospective where we sort of defined the good things and bad things in our application and came up with 2 different ideas to explore. One of them was GraphQL and the other was a pure domain-driven design idea. Spoiler alert, we went for GraphQL. So if you remember, this is how our application used to look like. So we were making requests to a content API, and we had a happy server, we had a Redux store, and we were server-side rendering our application. And now this is how our application looks like. So we're still making requests to the content API, but essentially we've added a GraphQL layer, and we're still using Happy and using Apollo client to make requests to our GraphQL server, which we use Apollo server to do the schema. And we're still React server-side rendering our React application. So essentially we got rid of Redux and we have this GraphQL layer that sort of protects our application, and all the business logic has moved from this side to the GraphQL layer. So what did GraphQL give us? Firstly, it gave us instant documentation. So this is a screenshot of another application you can query a GraphQL API. It's called GraphQL Playground. And you see here, this is how our schema looks like. And you can see clearly all the queries that you can make, all the arguments that the query requires and their types, and which ones required and which ones are not. You can see all the data that you can fetch, so you can fetch one or more of those data. So now our documentation is actually useful. It stays up to date with no effort. Another great thing that we found with GraphQL is that we no longer have to fetch data with multiple requests in our main application. So if you remember the Meghan Markle article and those chain of requests we had to make, now we just make one query. We still have to make the same requests, but they essentially move to our GraphQL layer. And as developers, we just have to think about when we're building our client-side application, just one query. So it kind of helps clear your mind a little bit. So now we can fetch data in a clear, consistent way. All the logic for gluing the data together has moved to our sort of GraphQL, and it does it seamlessly. Example of this is our recommendation component, which lives in the article page and the gallery page. So the logic to get this recommendations data lives in a GraphQL resolver. So we use it here in the article page and the gallery page in a similar way. So we can use the same query to fetch those 2 data, and if we change our the function that resolves this from the content API, it happens seamlessly on both articles. But previously we would have to replicate the business logic on both of those pages. So our lives are much easier now. We don't have to think about anything. We only have to think about one query. Another great thing, another huge benefit that we've got with GraphQL is that it encourages good patterns of structuring our application. We started fetching only the data we needed. We stripped out all our business logic out of our components, and we started to have true separation of concerns. We started using field names that actually meant something to us, not just what the API gave us. And now our UI is no longer tied to this API. Disclaimer, we could have done this without GraphQL, and you can do it without GraphQL. With more discipline, we could have avoided some of these problems. And if we also enacted some of these patterns, we could have had these similar benefits. So with domain-driven design and hexagonal architecture, they both have the same principles where you would have separate your user interface from your business logic. So GraphQL will not fix everything. But with GraphQL, it encourages traditional programming patterns without requiring developers to police each other. GraphQL allows you to follow these patterns without even having to think about it. It's just, that's how you do it. That's the GraphQL way. GraphQL has a huge community. You can go to these talks, watch videos about GraphQL and learn about these patterns. Not a lot of people know about domain-driven design or hexagonal architecture. Yay, GraphQL! One of the hugest benefits from using GraphQL is that now we have assurance that if we change our third-party API, our application won't be affected as much. So changing our data source would only affect the GraphQL layer, and our application doesn't really know about that. So it's shielded from that change. So situations that might occur. So if we switch CMSs to WordPress, for example, so here our pink API and we change it to a rainbow API, really our GraphQL layer knows about this. So those fields would resolve to a different API. And this React application really wouldn't know about that change. It would be making the same queries and going on with its business. So you just need to update a function in the resolver in the schema. Another example is, what if the business say, now in Vogue website we want to show shoe content, and we need to make requests to a show API. How would that look like? So if we had these two APIs, our GraphQL layer would just resolve those fields from the relevant API. So if it was getting shoes, it would go to the rainbow API and say, give me shoes. And if it was just the normal content, it would go to our CMS and get it from there. But our React application it wouldn't really know about this complication. It's just really on the GraphQL layer. So our application is resilient to any change that the API developers or the business decide to do. So if our API changes, our application is resilient. And we can react to any sort of technical changes that happen, and we won't be devastated by it. So why might you use GraphQL?
So this is why we use GraphQL, but here are some use cases that we're imagining that you might want to use GraphQL for. Use case number 1. You're building an API that has multiple consumers. And by this I mean, what if you have an API that serves different applications? Like it might be serving both the Vogue web application and also a native application, a native app for Vogue. The good thing is that GraphQL is what I would call product friendly, by which I mean there's a lower barrier to entry for new consumers to an API. It reduces the burden on consumers to perform logic because it's all done in the GraphQL layer, which shields consumers from all of the gluing together of requests. It does not enforce a specific way to consume an API, which gives consumers the flexibility to request data in the way that they want it. So if we're rendering a beauty category page in our web application and we want 10 articles, this is what our query would look like. We asked for 10 articles and we want a title and an image for both of them. But then if we want to render a beauty category in our native application, but we only want images, we don't have to be burdened with those articles. So we can just ask for the images that we want, and that's all we'll get back. So you will improve the experience of other developers using your API if it is GraphQL, I think. Use case number 2. You're building an application which has multiple data sources. So you can use GraphQL as a layer that allows you to get data from many different places. You can combine data from pretty much anywhere, but only interact with one interface in your main application. For example, you could get data from a REST API, a GraphQL API, and a database and smush it all together. So it would look like this. So our app is getting data, the GraphQL layer is getting data from 3 different places, 2 different APIs, and 1 database. And And our React application, which is serving the website, has no idea because it's just interacting with GraphQL and it has a consistent schema. It doesn't care where the data comes from behind the scenes. Note, GraphQL and REST are not mutually exclusive. What we've described in this talk is using GraphQL as a layer on top of a REST API, and you can do the same. So you can put GraphQL as a layer over REST APIs, other GraphQL APIs, a JSON file, a database, random things in your file system, and your main application won't care what's happening behind the scenes. Your resolver functions will handle all of the complication. Use case number 3, you want to enforce structure in your code base where there was no structure before. GraphQL encourages good habits. It will help you to separate your concerns. And it will encourage you to remove logic that is specific to third-party APIs from your client application. Yay, GraphQL. Number 4, you've built your REST API like a pseudo GraphQL API anyway. Do you have one endpoint which fetches fields based on a query param? It might look, well, it's basically already GraphQL. If you've seen an API that looks like this, where there's one endpoint, content, and then there's a query param where you say what fields you want, so say I want title, author, and body, this is familiar because it's kind of GraphQL. So if you have an API like that, just make it GraphQL. Lean in. Use case number 5, because it's fun and everybody else is doing it. Note, this is not the only reason that you should choose a tool, but combined with all the other amazing factors that make GraphQL so lovable, I think it's another great reason to use GraphQL. Note, we are not sponsored by GraphQL. We're just really big fans. Thank you, and long live GraphQL.